Conductors entering a panel board or any enclosure that houses overcurrent protection devices must not be spliced or tapped inside or between those enclosures. This requirement is outlined in the 2020 National Electrical Code, specifically Section 110.14c. The reason for this prohibition is primarily for safety and to ensure the integrity of the electrical connections. Splicing within an enclosure introduces several potential risks. Firstly, a splice represents an additional point of failure. The connection, if not properly made, can become loose, leading to increased resistance, heat generation, and potentially an electrical fire. Secondly, the presence of splices can make it difficult to trace circuits for troubleshooting and maintenance. A jumble of wires and connections can obscure the original wiring scheme, making it harder to identify the source of a problem or to safely disconnect the circuit. Thirdly, enclosures are designed to manage heat dissipation from the installed components. Introducing splices can increase the overall heat load within the enclosure, potentially exceeding the enclosure's designed capacity and leading to premature failure of components. Fourthly, the available space within an enclosure is carefully considered to ensure adequate working clearances and proper wire bending radii. Splices take up additional space and can impede the ability to safely and effectively work on the electrical system. The NEC prioritizes the safety and reliability of electrical installations. Prohibiting splices within enclosures helps to minimize the risk of electrical hazards and ensures that connections are made in a controlled and accessible manner. The correct approach when conductors are too short to reach the intended breaker is to extend the circuit from the junction box outside of the panel, maintaining the integrity and safety of the internal panel wiring. When dealing with electrical installations, it is crucial to consult with a qualified electrician who is familiar with the local codes and regulations. They can provide guidance on the appropriate methods for extending circuits and ensuring compliance with all applicable safety standards. Remember that electrical work can be dangerous, and it is essential to take all necessary precautions to protect yourself and others from harm. Always to energize circuits before working on them and use appropriate personal protective equipment. If you are not comfortable working with electricity, it is best to leave the work to a qualified professional. The NEC is a comprehensive set of standards that is updated regularly to reflect the latest advancements in electrical technology and safety practices. Staying informed about the NEC requirements is essential for anyone involved in electrical work. In addition to Section 110.14c, there are other NEC sections that may be relevant to splicing and terminating conductors. For example, Section 300.14 addresses the length of free conductor at outlets, junction, and switch points for splices or terminations. This section requires that sufficient extra conductor length be provided to allow for safe and convenient connections. It also states that all splices must be made in approved enclosures. Section 314 addresses outlet boxes, conduit bodies, and handheld enclosures. This section provides requirements for the size and type of enclosures to be used for different applications. It also specifies the number of conductors that are permitted in an enclosure. Section 312 covers cabinets, cutout boxes, and meter socket enclosures. This section provides requirements for the construction and installation of these enclosures. It also specifies the clearances that must be maintained around electrical equipment. Section 408 covers switchboards, switchgear, and panel boards. This section provides requirements for the construction and installation of these devices. It also specifies the overcurrent protection that must be provided for electrical circuits. Understanding these NEC sections and others related to wiring practices can help ensure that electrical installations are safe and compliant. When conductors are too short, there are accepted methods to rectify the situation without violating the NEC prohibition on splicing within the panel. Firstly, install a junction box outside the panel. This box allows you to extend the conductors using approved splicing methods. The junction box must be accessible and properly labeled. Secondly, use appropriately sized conductors for the extension. The new conductors must be rated for the same voltage and amperage as the original conductors. Ensure that the wire type is suitable for the environment and application. Thirdly, make secure and reliable splices. Use connectors that are listed for the purpose and follow the manufacturer's instructions. Common splicing methods include using wire connectors, crimp connectors, or terminal blocks. Fourthly, properly ground the junction box. The junction box must be grounded in accordance with the NEC requirements. This ensures that the enclosure is at the same potential as the ground, reducing the risk of electric shock. Fifthly, label the junction box. The junction box must be labeled to indicate its purpose and the circuits that it serves. This helps to identify the box for future maintenance or troubleshooting. The goal is to maintain a safe and reliable electrical system while adhering to the NEC. Shortcuts or improper wiring practices can lead to serious consequences, including electrical fires, equipment damage, and personal injury. Always prioritize safety and compliance when working with electricity. Remember that electrical codes and regulations can vary depending on the location. It is essential to consult with a qualified electrician or local building inspector to ensure that your electrical work meets all applicable requirements. The NEC is a living document that is constantly evolving to reflect the latest advancements in electrical technology and safety practices. Staying up to date on the NEC requirements is crucial for anyone involved in electrical work. There are various resources available to help you learn more about the NEC. The National Fire Protection Association, or NFPA, publishes the NEC and offers training courses and educational materials. Local electrical inspectors can also provide guidance on NEC requirements and best practices. There are also many online resources available, including websites, forums, and videos. The key is to stay informed and to take the time to learn about the NEC requirements. By doing so, you can help ensure that your electrical work is safe, compliant, and reliable. Also, remember that the NEC is not a design manual. It sets minimum safety standards, but does not provide guidance on how to design an electrical system. The design of an electrical system should be performed by a qualified electrical engineer or designer. They can consider factors such as load calculations, voltage drop, and coordination to ensure that the system is safe and efficient. The NEC is a valuable tool for ensuring electrical safety, but it is only one part of the equation. Proper design, installation, and maintenance are all essential for a reliable electrical system. When working with electricity, it is always best to err on the side of caution. If you are not sure about something, ask a qualified electrician for help. Taking the time to do things right can save you time, money, and potential headaches in the long run. In summary, splicing conductors within electrical panel boards is generally prohibited by the NEC. This prohibition is in place to ensure safety and to prevent potential hazards. When conductors are too short, there are alternative methods to extend the circuits, such as using junction boxes outside of the panel. Always prioritize safety and compliance when working with electricity. By following these guidelines, you can help ensure that your electrical installations are safe, reliable, and compliant with the NEC.